So let us introduce ourselves. Hi, I'm Anil Kumar. I'm glad that you all are there for the class. We are actually learning about advanced functions, which is a curriculum in Toronto, Canada. So can you please introduce yourself one by one? Let's start with Vishruta.
Hi, my name is Vishruta. I'm doing advanced functions in the summer with Anil sir, so I can be prepared for school.
Hamza.
My name is Hamza. I live in Oakville. Ontario, and I'm going to grade 11 this year, and I'm just trying to get ahead certain functions. Advanced functions.
Akshit.
Hi, my name is Akshit Kandivanam. I'm going to grade 12 next year, so I thought it'd be best to revise and prepare for advanced functions.
Ankita.
Hi, my name is Ankita. I'm going to grade 12 this coming year. Advanced functions is a great or very effective and very interesting course, and I wanted to get ahead of it before school starts.
Glad. So it's actually very nice that you have taken up this advanced functions well in advance. The semester starts within a week's time, and you have already done 5 units. That's great. So today we'll review basics about inequalities and move on to rational functions. Okay. So let me share with you my screen, and then I wanted to start with rational functions. Since you wanted to do inequalities, let me just take that out. So quickly, we'll go through inequalities. Can you all see my screen, please?
Yes, sir.
Okay, so we'll learn about basic inequalities in just a minute. We'll see the inequality and the interval notation. We'll have an example on linear inequality and on number line. We'll see how polynomials are solved using inequalities, algebraic solution using factoring, right? That's what we'll do actually. Okay. So basic inequality. What does it mean? You know, if I say y equals to x, what does that mean? Y equals to x, we're looking for a set of points where y is equal to x, correct? So that basically lies on a straight line, which is diagonal, as you know, right? So this line is the line for y equals to x. So every point on this line represents this particular equation, y equals to x. It is an equation, it has equal to sign, correct? Now, let me change this. If I say y is greater than or equal to x, that really means we are looking for y values which are greater than x or equal to x. So y is represented on the vertical axis, x on the horizontal, x being the independent parameter, correct? So when I say greater than equal to, that means the region which is above this, correct? And also includes the line. We get the idea? And also includes the lines. This and the line itself. You see that? So when we have an inequality, we have a region, as you have seen on this particular graph, correct? So that is kind of difference between equations and inequalities. Equations may have no solution, one solution, many solutions. Inequalities could have many solutions and also a region, as we saw in this particular example, correct? Now, this solution is normally represented in many different ways. We'll see how the solution for an inequality is represented. So there are 3 different ways in which we should actually represent a solution of inequality. One we call as number line. So on a number line, you can show the solution. You can use interval notation, which is shown here within brackets, or with the help of inequality sign itself. Okay. Now, few important terms. On a number line, as you can see, I have marked in red A to B, right? Where the circles at A and B are not filled in. or they are open circles. That really means that in the solution, A and B is not included. And in interval notation, we use by these brackets. That means A and B is not included. And if I write this in terms of an inequality, then we write X is greater than A, but is less than B, right? Do you see that part?
So, sir,
Yes.
so basically you're trying to say here that the solution is in between A and B?
Yes, not including the boundary.
Okay, so
But if the
so it
boundary
can't
is
be more
included,
than, so it can be more than or equal to A and can be more than or equal to B.
less than B, yes.
Okay.
But if it is included, we put in filled in circle and the bracket is changed to this square bracket. You see that? And we have inequality greater than equal to, right? Greater than equal to. Do you see that? So X is greater than equal to A, but less than equal to B. A and B both are included. You get the idea. So that is called the closed interval, where the boundary is included. We could also have infinite interval, that is, as in our last example we saw, X greater than Y, all values of X, right? We had this going arrows showing on both the direction, means they're going to infinity. Infinity can never be included, therefore always this parenthesis will be used. Is that clear to you, right? But A, if it is an open circle, then it will not be a closed bracket. You get the idea, correct? So that is how we'll actually show the proof for inequalities. Let us say I can also show like this. I can show like this. Sometimes instead of a circle, we put a bracket itself, right? Do you see this bracket? So if I do like this, for example, like this bracket, that means the point is included, right? And if I write this point as P and this point as Q, how will this inequality be written? Can anybody tell you? Okay, Hamza, can you tell me how to write this inequality in this term, inequality notation?
So the first one would be X is greater than P.
Less than equal to P.
Sorry, yeah. And then the second one would be X is greater than Q.
You can say union, or you can use the word or you can use semicolon. Q, X is greater than equal to Q. Is that clear to you?
Greater than or equal to? Is it because the circle is closed?
Yeah.
Oh, okay. So every time, so for a bracket, does that mean circle is closed?
Yes.
Oh, okay. How would you show like an
important.
open circle bracket?
Yeah. This is a bracket. This is a square bracket. That is why it is closed. Okay.
Okay.
Okay. Now, do you see in inequality notation, I have written two different inequalities to represent the situation which has a gap in between, correct? So whenever there is a gap in between, those many different inequalities will be written as a part of solution. Okay? Very important. You cannot write it like this. I mean, if you write that X is less than equal to P or something, sometimes like greater than equal to Q or something like this, that will be wrong. Don't mix it up like this. Do you understand? You have to write it separately. Very important. Let's do some. Yes.
Sir, can you go back for just a second?
Yeah.
So you can either write it separately or use the union sign, right?
Yes, you have to write separately with union sign if you have a gap in between.
Okay, yeah. Go ahead.
Also, what did you say that the square parentheses, like what did that represent?
Included. Square means included.
Yeah, okay.
It's like filled in circle. Same as filled in circle. Okay. So some books use square on the number line itself. Is that okay? Now express the interval in terms of inequalities. So first one, how will you write this? 2 to 5? Correct? X is greater than minus infinity, less than equal to 1. So we'll write X. You need not write anything here, right? The only thing you'll write here is X less than equal to 1. Do you see that part? How will you represent from minus infinity to 1? It means basically less than equal to 1, correct? Minus infinity is included now, kind of, in the solution, right? But if we have boundary on both the sides as shown here, then it will be from minus 3 to 5. Correct?
I don't understand how you did that. Can you go
Which
back?
one?
Just all of them in general. So the first one, how do you know 2 is greater than x? Like the first, like, yeah. I
We
just
are
don't
trying to
understand.
write this interval from 2 to 4 in terms of inequalities, right? That means
Mhm.
what? It means that x is between 2 and 4, both of them not included, correct?
2 and 5, right?
Yeah. Oh, sorry, 2 and 5. Yeah.
Yeah.
So that's what I wrote, correct?
And then
2
for
and
the third
5,
one, how is it? That was the first one and the third one different. Like, how are the intervals?
square bracket.
Oh, okay. That makes sense. Okay, and okay, so that's what you're trying to know. Okay, so the second one had an open and then a square. So
Yeah, but even if I say x is less than equal to 1, it means the same thing. Do you see that?
okay, so can you just write a small note at the bottom? What does a square bracket mean? Or what does like a open, like just a normal bracket mean? I'm just gonna write that down so I don't make a mistake again.
Included.
And then square bracket is
Not
not
included.
Okay.
Yes.
Okay, that makes sense.
Try to do this one. Express each of these inequality in interval notation. Can you tell me x greater than 5? How will you write? In interval notation.
So
Not inequality. Tell me.
Wouldn't it be
Well,
5 to infinity in parentheses?
In parentheses, yeah,
Greater than
because
5.
x is included, right?
Greater than 5 will be 5 to infinity. Greater than 5. So on the right side of 5. Do you get the idea?
Mhm.
The next one. How will you write the next one? From -1 to 1?
You would be square brackets and -1, comma 1.
Correct. And then this one?
X is less than 0 and x is greater than
So
equal.
yeah, so you start with open bracket and then it's closed.
Minus infinity to 0,
And then
union
you'd union.
3 to infinity. Is that clear to you?
Mhm.
Let's do this question. 2x minus 3 greater than equal to 7. How are we going to solve this question? Very simple. Add 3 both sides, right?
Sorry, so you would isolate the 3, so yeah.
We isolate
3.
2x. So you get 2x greater than equal to 7 plus 3, right? Which is 10, correct?
Yeah.
Now you divide by 2.
Yes.
X is greater than equal to 5. That is your solution, right?
Yes.
If you want to write this solution on a number line, you will write like this. Let's say this is 0. The solution is greater than equal to 5. The filled in circle, that becomes the solution. Clear?
Mhm.
How will you do the next one? Anyone?
So you would move 1 to the other side, so it'd be half x is less than 4. And then you just
And then you,
divide
yeah,
4
multiply.
by halves. The 8.
Yeah, basically.
Correct. Is that clear, right? So you can write this as from minus infinity to 8, correct? But if the question is to write on the number line, so from 8, we'll go like this. Is that okay? Next one, this is okay. I like Hamza. Solve this. 5 minus 2x over 3 greater than equal to 9. How will you do it?
5 minus 2x. First thing I do is I multiply by 3. The whole, like the other side by 3.
Correct. Then
So now you have 5 minus 2x. So now I isolate. Okay, so now I add 5 to the other side.
minus 5 both sides.
2. Then
Now,
so yeah, and then now I would divide by -2.
what will happen? Tell me now.
Yeah, 11.
What happens to inequality?
X is greater than equal to.
No, the sign will reverse. When you multiply by a negative number, the inequality sign will reverse. That is the major thing. That's why we have done this question. Do you understand?
Okay.
You know, the 7 is greater than 5, but as soon as I multiply by negative number, then we have minus 7 is less than minus 5. Do you see that?
So the answer would be -11, right? X
You're
is
right.
less.
You're right. Negative 11. Good job. So we're dividing by -2. So the answer will be -11. And on a number line, clearly, the answer will be from negative, let's say this is 0, it will be from -11 filled in left side.
So if you were to write this using interval notation, it would be first parentheses, then negative infinity to negative 11,
Correct.
and then square bracket, right?
So every time
Oh,
you're just
yeah, I'm
dividing,
sorry. Square bracket for
so-
11. Yes, yes, yes.
so it's just every time you're dividing by a negative number or multiplying by a negative number, the inequality changes.
Yes.
Okay.
You could have taken minus 2x on this side and that on the other side, you'll get the same answer. Okay? You understand what I'm trying to say? Let me just show you. I could have done from here something like this. 5 minus 27, bringing 27 to this side greater than or equal to 2x, taking 2x on the other side. You get the idea? Now I divide by 2, we get minus 11 is greater than or equal to x, which is same as x is less than or equal to minus 11. Do you see the same answer? So in that case, there is no confusion about multiplying and dividing by a negative number. Okay? Next question. Akshat, please read the question.
Graph of a cubic function f of x and a linear function g of x is given below. Write the interval in which f of x is less than g of x.
F of x is linear. We want the linear function to be greater, less than g of x. What is the solution from the graph? Tell me.
Okay, so
So cubic
For-
function is f of x.
yeah, and the linear function is g of x, right?
We want f of x to be less than g of x, right? Tell me the answer.
So you'd have to check when
They're
f of x
intersecting here, yeah. These are
Yeah.
the points of intersection, right? Tell me the answer now.
So I can't see the points properly.
Okay. Let us say A, B, and C. Let's say this is A, this is B, and this is C. Now tell me.
Okay, so at point A, g of x is increasing and g of x is increasing and f of x is decreasing, right?
Yeah.
So it would be that point included, which looks like -3, right?
So x value -3 is correct.
-3.
That is
then
-1.
Yeah,
And then
it would be -2.
no, this is 0.5, 0.5, you can say 0.5
Okay.
to infinity, right?
Oh yeah, sorry, yeah.
Because
The
thereafter
scale is
it is
going
higher.
down.
Correct? Is that clear? So from the graph, you have to read it properly, get the answer as we just did. No problems. Last question. Okay, question number 7. Ankita, can you please solve this question? X square minus x plus 7 greater than or equal to 1. How will you do it?
I think you first take the 7 to the other side. So x squared minus x.
We will rather bring 1 to this side so that we have a quadratic equation. We'll factor this
Oh,
and use
okay.
graph or interval table to solve. Okay? So
Oh,
let's
yeah, that
factor
makes
this.
much more sense.
Yes. Now factor. Product and sum for 6, right? And -1. What do you get?
X minus 3, x plus 2.
Yeah.
Now tell me, when is it positive?
Sorry, when is it positive?
Yeah, because greater than or equal to 0 means positive, correct? Equal to 0 also works, correct? So we have zeros at
X
and
plus,
minus
plus 3 and minus 2.
correct. So if I have to draw a graph which will be positive leading coefficient, it will be kind of like this, correct? Where this
Yeah.
point here will be at -2, this point here is at 3. What is the solution? Correct?
You would add the union because there are 2 zeros.
During this half, left side and right side, the graph is greater than or equal to 0. That becomes the solution. Clear?
Yeah. So
Yes.
yeah,
Sorry,
go ahead.
go ahead. Sir, I had a question regarding the table that you're saying.
Yeah.
Can we go over that?
Yeah, sure, we'll do this. Again, we'll do with table also, no problem, that's better. So let's see, how do we solve the same question using interval table, okay? So what we learned here is that we have two zeros. Two zeros will divide the plane in three parts, correct? So as far as the zeros are concerned, the zeros are at -2 and at 3. That means we have an interval from -infinity to -2, from -2 to 3, and from 3 to infinity, correct? These are the intervals. In these intervals, we'll take a test point. So a test point in this particular interval could be like -3. Here 0 is a good test point, right? And here we'll take 4 as a test point. You can write down the factors. It is good to write factors in the way they come in that particular order, right? So it is good to write like this, x plus 2 and x minus 3. If you substitute, let me write down these factors here itself. That is at 0 at -2 and x minus 3, 0 at 3. So in the first case, -3, if I substitute, I get negative. If I substitute 0, I get positive. For 4, again, I get positive. We have to only see the sign, not the value. In this case, -3, negative, negative, and this also is positive. So if you multiply two negatives, you get a positive. A positive and a negative gives you a negative. Two negatives gives you a positive. We are looking for greater than or equal to 0. So positive is our solution, correct? So these two intervals are part of solution, which is this. Do you see that?
Oh, sir, yeah, I got it now. So,
Yes,
sir, if
that's
it was
part-
negative, then we would choose the
Center
negative.
Correct. Is it
And
clear to
center.
all of you?
Another quick question.
Yeah.
We found the product of the signs, right? For x
Yes.
plus 2 and x minus 3.
Yes, yes. Because the function is a product. Do you see? F
Yes,
of
sir.
x is x minus 3 times x plus 2. That is why.
It's always finding the product, right?
Product, as the question is. Product,
Okay.
in a rational function, there could be a denominator also, right?
Denominator, yeah.
That's also a product in a way by reciprocal of that, correct?
Yeah.
Okay. Let's do this interval table with a polynomial. Now, Akshat, have you really understood this process?
Yes, sir, the table, I think I have.
Now tell me, how will you do it?
You would first use distributive property to
No,
solve
first you find out 0.
Oh, find the zero,
It's
sorry,
already
yeah.
factored.
Yeah, it's already factored. I didn't see that. Yeah.
So first 0 is at 1, this 0 is at 3,
3 and then
and this 0
negative.
is at -2. Is that clear?
Yeah.
So you got these zeros. Now these zeros will divide the whole interval into 4 portions, correct? So let me show these 4 portions. 1, 2, 3, 4. Correct. So I'm also drawing one line just to write down my values. So here we have a 0, which is at -2. Then we have a 0 at 1, and we have a 0 at 3, correct? The multiplicity of -2 is 2, right? Which is a square term. Now this divides into intervals, and let me write interval like this: -infinity to -2, from -2 to 1, 1 to 3, and 3 to infinity. Let's take test points in these intervals. Okay, Akshat, what test point will you take? You're on mute, Akshat. So from
sorry, sir.
-infinity to -2, let's take
We can take-
-3.
Yeah, it
This
is.
was a good point. 2 and 4, correct?
Yeah.
Write down all the factors. There is a constant. So I will write this x plus 2 whole square first. That was my first 0, right? So I'll write x plus 2 whole square. That is my factor, correct? Then 2 times x minus 1 I am writing. And then I'm writing x minus 3. You could write in any order, but I prefer to write in order of zeros. Is it okay? Now, if I test the sign, positive for square, correct? This is always positive, correct? Because x plus 2 whole square is going to be positive, whatever is the result, right? Now, 2 times x minus 1, 2 is a constant. It is always positive. We are looking for x minus 1. X minus 1, if I substitute minus 3, I get negative. 0, I get negative. If I plug in 2, I get positive and positive. For x minus 3, minus 3 gives me negative, 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 and positive. Do you see that? So let's see the function. What happens to the function? Which is product of all of them. So in the first case, the function becomes positive, then it is again positive. Here it is negative, here it is positive. We are looking for a positive answer, right? Greater than or equal to 0. So we have solution in these intervals. Do you see that part?
I just missed it for a second because I just had to do something real quick. But how did you get the plus 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 minus? Can you just review that?
Just multiply these three terms. When there are two negatives or even number of negatives, you will get positive and you multiply them, correct?
Okay.
That
Negative and negative. So negative, negative, you get positive.
Yeah.
Negative. Okay.
Now, so that is using interval table, you can find the solution. Is it okay?
Mhm.
You could also do it graphically. Now, can you sketch this graph and see or confirm the result?
So
Let
to
me-
sketch the graph, we would have
Yeah.
to find the
So
multiplicity.
we have a leading coefficient positive. The first one is a order 2, right? So the graph will turn here, right? The other side, it will cross. And therefore, if I draw a graph, it will be kind of like this. Do you see that? Degree 4, correct? Do you see the graph? Let me draw it in a different thing. Do you see that? So what do we notice? Only in this half it is negative, but it is positive everywhere, correct? So those are the solution sets, correct? So you don't even have to do the interval table if it is allowed to do with graph. In this case, we wanted it graphically. So that is how you'll solve it very easily. Graph the polynomial. Is that clear to you?
Yes.
Okay. I'll take up a communication question based on inequalities. Question number 11. Hamza, can you please read the question?
Explain why the following strategy fails to solve the inequality. Provide correct solution.
Correct. Go through this strategy. Tell me what is mistake here.
Okay, let's see. X minus 3 plus 1.
X minus
So-
3 times x plus 1 is less than or
Okay.
equal to 5 minus x. So I cancelled x minus 3, x minus 3.
You okay? So you X. Okay.
And I got x plus 1 is less than or equal to 5 minus x. And I solved and I got x is less than or equal to 2. Where is the mistake?
Hmm.
There is a mistake.
I feel the first step is fishy.
What is the mistake?
Oh, okay. You took the negative x from one side. Did you make it positive when you tossed it?
No. Okay, anybody else? Anybody else? What is the mistake here?
So just to
Yes.
guess, are you allowed to cross out the x minus 3 like that?
You are not allowed to cross.
So isn't that the mistake?
That is why I'm telling you it is a mistake. Because x minus 3 could be negative also. You get the idea, because you don't know what x is. If x is minus 1, x minus 3 is negative. And when I divide by negative, I have to change the inequality sign, correct? Which I didn't. So the way to solve it is you have to actually bring it on the left side. You never cancel in inequalities. So in equation, you could have canceled, not in inequality. So you'll bring it to one side. You say x minus 3 times x plus 1, bring minus 5 minus x times x minus 3, is less than or equal to 0. Now you solve it. You get the idea. Don't cancel. Now x minus 3 is common. You get x plus 1 minus, you get 5 minus x less than or equal to 0. So you get x minus 3 common. Simplify this. X and minus x becomes 2x, minus minus, right? Let me rewrite like this. X plus 1 minus 5 plus x. So we get x minus 3. And here we get 2x and then minus 4, correct? Is that clear to you? So we have one more solution. Not only this, there is one more solution. There's another 0 here. Do you see that? So there are two zeros. If I really want to graph it, one 0 is at 3, the other one is at 2, right? So if I put x as 0, then I get 12 as my positive value. So the graph is kind of like this. There's less space, I'm just sketching it, right? Do you understand? The two zeros are at 3 and 2. And we want to be less than 0. That means this is the solution, correct? Less than equal to. So solution is between 2 and 3. Do you see that? So this is wrong solution. Do you understand the concept? Vishruta, did you understand how we got the solution?
Yeah.
Any doubts? So we got 1, 0 because of this. X minus 3 equals to 0 at x equals to 3. So we got that 0, right? Then we have 2x minus 4 equals to 0, means 2x equals to 4, x equals to 2, correct? 4 divided by 2, this solution. When you multiply them, you get a negative number. So we want less than 0, so in between. Do you see that? So that becomes the interval. So on a number line, you will show your solution with from 2 to 3.
Sir,
Yes.
I have a quick question. In the first line where we took 5 minus x and x minus 3 to the other side, right?
Yeah.
Sir, so if x minus 3 is present twice, we can just take it common.
If you cancel, you lose the solution and you get a wrong solution. You see that? The solution which you get was, as you've seen all this, x is less than equal to 2, right? This side of this, right? Which is a wrong solution. You can see that, correct?
Yeah.
So this is a mistake. That is why this is a communication and thinking question. It comes in the test paper. Very important question. You have to communicate in each and every line why you cannot do it, why this statement is wrong. This statement is wrong because x belongs to real numbers. It could be negative. So x minus 3 could be negative. If you're dividing by a negative number, you have to change the inequality sign. You get the idea? But you just cancel. You never change the inequality sign if it was negative. So you have to be very careful. So bringing it to the left is a safe thing. So safely I've factored it out and I have not actually made a mistake. And I got the right answer. Correct? Very important. Okay. Okay. So actually we'll continue with inequality since, very less time is left for the rational functions to be introduced. Let me take another good question here. Now we have an inequality. Okay. Vishruta, can you please read the question?
Create a linear inequality with both constant and linear terms on each side for which the solution is x is
less than equal to 7. How will you do? Now we have to do backwards. You have to get the inequality whose solution is x less than equal to 7. And that inequality should be at least a linear inequality. You get the idea? How will you do this question? Tell me. We need both a constant and a linear term on each side. At present, we have a constant on one side and we have a linear term on the other side, y equals to x. Is that clear to you? So we have to make an inequality which has both the terms on both the sides. Anybody?
Sir,
yes.
You can do 3x plus 3 is less than or equal to 24, right?
Okay. So what we could do is, as you're trying to say, let us add 3x on both the sides. You could do that, correct? Add 3x on both the sides. It is not changing the inequality. Inequality is still the same, right? You want constant term here. Okay, fine. Add a constant term. So what do you get? You get 4x plus 1 less than equal to 3x plus 8. So you have an inequality which has linear terms and a constant term on both the sides, correct? And if you want to solve it, you can solve it. 4x minus 3x is less than equals to 8 minus 1, which means x is less than equal to 7, correct? You get this solution also. So we have formed an inequality whose solution is the given answer. So that becomes the answer for our question. Do you get the idea?
Sure. So there's a diverse amount of answers for questions like these, right?
Pardon? Pardon?
There's a lot of answers for questions like these. Right?
Yes, yes, yes. Many answers. Of course,
Okay.
you could add anything, right? But the idea is you have to add a linear term on both the sides. Is it okay?
Yes. Sir.
That was the question. The last question here. Oh, solution is given to us. No problems, because, I'd like you to copy this question. You can get this particular question in your test paper. This is from a test paper. In a test, it is very difficult question to do since you have a quartic equation, degree 4 polynomial, correct? On both the sides of the inequality. So the question here is solve 3x squared times x squared minus 8 plus 6x plus 10. On the other side, it is 4x to the power of 4 minus 6x times 4x minus 1 plus 9. Now, if you have inequality of this kind, the strategy is simple. Bring all the terms on one side. Is that clear to you? So after you expand, which is the distributive property, so first thing, apply distributive property, right? And then you bring all terms to one side. And then simplify. And then factor. And then you analyze. You understand? Follow all these steps.
Sir?
Yes.
So after factoring, we can just go ahead with the interval table, right, sir?
Yes.
And then, okay.
Analyze. Yeah. You could do interval table or graph and get your solution. Just as we got the solution here, right? But important thing is, in this particular case, distributive property, how do you expand polynomials, simplify them? All those things are very critical from test point of view, right? Because in a test paper, you're in high tension, right? So you have to do very carefully. It's a very simple question otherwise. Once it simplifies to x to the power of 4 minus 1 greater than 0, right? And you see greater than 0 because there was negative. So when there was a negative term, I multiplied by negative and changed the sign. So there could be a possibility of an error in the stage. So you have to be very careful when you simplify and get all the terms to one side to solve it. Is this point clear to you? Second, do you understand how I factored x to the power of 4 minus 1? Is this step clear to you?
Yes, sir.
Okay. Okay, if it is clear to you, no problems. And then you really solve this particular question as I've shown you. Correct? So you could use interval table. We clearly have two zeros, plus and minus 1, and they will divide the whole interval into 3 portions. Take test points in 3 portions, test all your points, and get your answer, just as we did in the earlier question. Okay? So I will not take a rational inequality. We do have 15 couple of minutes, right? So let me just add a page. I need you to participate actively and tell me the solution of this inequality. We're just writing at random. Let's say x plus 1 times x minus 2 divided by x. Is that clear to you? So tell me, how will you solve this? This is a rational function. We want that to be greater than or equal to 0. So that now becomes an inequality. I need solution of this using interval table. So how will you use interval table to solve this inequality? Tell me. We'll start with Hamza.
Yeah, so sorry. Yeah, sorry.
Hamza,
actually,
tell me. First,
Okay,
tell me
so-
zeros and discontinuities.
So zeros would be 1 and 2.
No, be
What-
careful.
Sorry, negative
No,
1 and negative
Negative
1.
1 and positive 2, I believe.
Yeah,
No.
negative 1 and 2.
negative 1. So zeros at negative 1 and positive 2. Is that clear?
Yeah,
So
that's
these are
your-
the zeros which could be the part of solution since it is greater than or equal to. So zeros are part of solution. I have put them as a solid filled in circles there, indicating that they could be part of solution. Is that clear to you? Now,
I have a
x equals to
question.
0 is
Sorry.
not there a part of solution because we have a vertical asymptote, and clearly for this function x is never equal to 0. Is that clear to you? That
Yeah.
will never be a part of the solution. Yes, what was the question?
So it says x is greater than or equal to 0.
Yeah,
It can't be less than 0, right?
no, the whole inequality, the whole function is greater than or equal to 0. So we have to check which region it is, right? So we are not talking about, let's take test points in the 4 intervals. So first test point, Hamza, what will you take test point in the first interval? Minus infinity to minus 1?
2.
Minus 2.
Minus
So
2,
you always
yeah, sorry.
miss the sign. Now, not good.
Sorry, minus 2, that's what I meant.
Yeah, you're going to do a mistake in the test paper based on what response I'm getting from you, right?
Yeah.
Okay, now write down these. So we'll write here, I will prefer to write x plus 1 first, then x, and then x minus 2, since that is the order in which I have written my zeros and all those points, correct? I prefer to write. You could write them in any order. Now, tell me, for x plus 1, if I use the negative 2, what sign do I get? Positive or negative?
Negative.
Minus.
Yeah, and all others are positive, correct? Now for x, well, clear. Test point sign, x minus 2, negative, negative, negative plus. Do you see the way in which positive and negative have come? They have come in an order only because I have written my factors in order, correct? Now, as far as the function is concerned, which is product of x plus 1 and x minus 2 divided by x. Now, if there are 3 negatives, what will I get? Negative or positive?
Negative.
2 negatives will give me a positive, 1 negative, negative, all negatives positive. We are looking for what? We are looking for positive, right? So this is the part of solution, correct? Now, Ankita, can you tell me what is the solution?
The solution would be, I think, f of x is equal to -1.
Include it.
That's the intervals, right? -1 to 0, and then I think it would be -2 to.
2 positive, man.
Sorry. I keep messing up the time, but yes, 2 to.
No, keep getting wrong answers.
Two,
Even
two
if
to-
you know it, you will not get full marks. You get the idea.
Okay.
So wait, does a union mean that there's two
Yeah,
solutions?
there are 2 intervals, right? It is positive here and it's positive here, correct?
Yes.
And there were these 2 zeros because of inequality equal to also, we'll include them as a part of solution. So that will be in interval notation. Yes.
So in our equation, right, x is not equal to 0 because of the asymptote, right?
Yes.
But we still have to include -1 included and then 0 with the parentheses, right?
Yeah, because we have greater than equal to, right? So
Okay,
0 is a part of solution in this case, correct?
correct. But like from a graphical perspective, the graph is never equal. X is
Yeah,
never
but
equal to 0.
as far as graph is concerned, not at 0. I mean, you can always sketch the graph, right? There is, in this case, we will learn that horizontal asymptote is actually at 1, and
Yeah.
we'll get x-intercept, y-intercept, but the y-intercept will not be there because there's a vertical asymptote at x equals to 0, right? So we have a vertical asymptote at x equals to 0, right? So it will never be a part of solution. Is that clear to you all? Correct?
Yes, sir.
So that is a good part of rational functions, which I wanted to teach you, but I have taught you the later half, which is how do we use inequalities in rational functions, correct? We'll end our lesson here, and I'd like you to share your learnings for today. We'll begin with Hamza. Hamza, what did you learn today?
Well, first thing is I learned to be very careful with the sign. I'm gonna get something wrong on a test. But in general, I just had a review of the interval table, and I learned about the inequalities, the open circles, the closed circle. I think we touched on that unit 2 or unit
Yes.
1. But yeah, so that was just more of a complex review. So I think that was nice.
Correct. Vishruta.
I learned about the inequalities. It was helpful to get all the little things that you usually get in questions. And I really liked the application questions part because it helped you see how it's actually going to happen in the school tests and stuff.
Akshat.
Yes, sir. So I really learned how to organize the inequality with the interval table and how to really approach the problem. And I learned that when we have a rational like inequality, right? Then even if the function is not equal to 0, it's still included within the solution.
Yes,
So
of course. Yeah.
that was
It is a
really
boundary. It is a boundary which forms
Right.
different intervals. Yeah,
correct.
correct. Ankita.
Yeah, so I think I learned about the inequalities. One thing that I did when I first came across inequalities in grade 10, I thought it was very like hard, and I didn't really understand it as much. But I think it was when we went into the lesson today, it was very in depth, and I was able to understand far from what I was expecting. And I did really like the different methods we used, for example, the interval table. And when we started off algebraically, I did really like the way we went from starting off algebraically, because that's what we've been doing for many years. And then we moved on to the table and then graphing. So I did like the procedure of how we did our lesson today.
Great. So try some questions from your book. If there is any difficulty, let me know. We'll review those things. And we'll continue with rational functions next time. Okay. Have a great day. Bye. Thank you.
Thank you, sir.